We are building the Fractals and Recursion project from the YByte Python curriculum available at www.ybyte.in. We just created our very beautiful first fractal, with very little code and an intricate pattern. Now, the interesting part about this code is that look at any square. In fact, it is similar to a square at a different. For example, let's say we look at, say, this square over here. Now, clearly, it has got two smaller squares on its arms, which further have two squares on their arm, which further have two squares on their arm. Now, in a real fractal, in a, let's say, ideal infinite world, this will go on forever. But obviously, for making it practical, we, limit this, and that happens from the base case. But clearly, you see that recursion is the enabler of something like this. This is how so many extra squares have come up. Now we are going to move forward and in fact apply this thought process to a new fractal, the tree fractal. But before going there, let's take a moment, pause, let's pause for a moment and just reflect on what's going on. When it was just one level of recursion, we argued that a for loop would have been just sufficient. It would have done the job for us. But to create something like what we just did with the for loop, I think will require a lot of unwieldy code. It will get quite hard to keep track of what's going on where. And hence recursion is helping us, because the recursive process takes care of the nested nature of the code. As I said earlier, fractals are thus best made with recursion. And on their part, recursion is also very nicely understood with fractals. That's why, again, a win-win situation. We are going to turn our attention to a new fractal, which is this tree. Now, first, let's understand why is this a fractal? Well, think about it. Just imagine for a moment that this thing was infinite. I start with one branch. I branch into two. Again, this branch branches into two. Again, this branch branches into two, and this continues forever. But obviously, for practical reasons, we are going to limit it. In our case, we'll probably have, let's say, 8 levels. So level 1, level 2, level 3, level 4, level 5, level 6, level 7, and level 8. But technically, this could go on forever and ever, and that's why this is a fractal. Another way to think about this is that, look, if I look at this tree, and I start seeing this tree, let's say from this node, I just look at this portion. In fact, again, it looks like a tree. And, I start seeing from here, again, it looks like a tree. So basically, no matter where I start looking at it from, it's in fact a structure which is sort of self-similar. And that's why this is a fractal. It's basically a bunch of Y shapes stacked onto each other. Now, if you look around yourself, you'll find that trees, in fact, very clearly show this behavior. And that is why I said branches of a tree are a fractal that is found in nature. Now we are going to use the knowledge that we have gained so far to draw this. At first look, this looks completely different from the square that we were drawing. But in fact, there's a deep similarity. And that's why the logic, in fact, follows a similar pattern. We will discuss this in the next video and then take it forward step by step from there. Clearly, this is a very unique way of learning where we are building things step by step manner and applying these ideas to different problems so that we understand how things really work. Do check out our website www.ybyte.in for many more such videos and such lessons. Take care. Thank you so much. Bye-bye.